This video is on phase changes or changes of state. This video is hopefully for the most part review, but I want to make sure that you remember this stuff or kind of learn a little bit more about it. So let's just talk about solids, liquids, gases first. Solids are high density, definite shape, definite volume, which means that the molecules in a solid are all very tightly packed. So like if this is a cross section of a solid and what I'm drawing are the atoms or the molecules, they're all tightly packed. There isn't space between them. Definite shape, definite volume means that if you move it or turn it on its side, it will not change. And the motion of the molecules is vibrational, which means they just vibrate in their location, but they can't move side to side. All right, so liquids have definite volume, meaning like if you take your liquid in your water bottle and you turn it on its side, it's still gonna be the same volume, but its shape will change. So there is some space between molecules or atoms when we're talking about liquids. What that allows then is you still have vibrational motion, but you also have translational, which means they can move side to side. That's what allows the shape to change because there's some space for them to move side to side. All right, so gases are the most different. Gases have very low density because the molecules are so spread out. They don't have definite shape or volume. They take the shape and volume of their container. So like if this were a cross-section of a gas, you actually might not see a single atom or molecule because they are so spread out. So I'm just going to draw one here. And their motion is random and rapid. And what they do is the way they move is they move in straight lines until they hit something. That's why we talked about, when we did gases, we talked about pressure with them because they're moving, so they're having more collisions with each other on the sides of their container, which creates pressure, or more pressure than like a liquid or a solid might have because they're not moving as much, if at all. So solids and gases are very different, whereas liquids and solids are much more similar due to their forces. There's forces holding their molecules together, their atoms together, which allows them to act more similarly. Okay, so let's talk about a graph related to, let's do temperature on our y-axis, and let's do energy down here, and I'm going to do time/energy because it would work with both. It would be true. All right, so if I have, we could just say water or any substance, low temperature before I've added much time or energy, but then as I add time or as I add energy, the temperature goes up. All right, what will happen is at some point, the temperature won't change. And then it will change again. We'll talk about what the difference between these are in a second. And then it will not change again, the temp, and then it will again. So what we're looking at here is we're looking at where something is a solid, a liquid, and a gas on this graph. And I'm going to do some dotted lines to separate these. Oops. Okay, so we have in this first part, this first increase, this is where your substance would be a solid. So it has not melted. The molecules are very close together. The temperature can increase in a solid as we add energy. And at some points when we get to this dotted line, we get to this flat part, this is where something starts to, if we're increasing our energy, melt. So in the melting phase, we have a solid and a liquid. Think about like an ice cube, for example. If you set an ice cube on the counter, energy is being added, it's heated up, the temperature is going up, and then it starts to melt. It's not like it immediately goes from a solid instantaneously, all of it's a liquid. You're gonna have both. As you're getting more liquid, you're getting less solid, right? As you add more energy. But during that time, the temperature does not change. All right, so then it gets to the point where it's all melted, and then it would be all liquid. And the temperature then will increase again. And then it will start to, at some point, where this dotted line is, it would start to boil or evaporate. So this is where we have, just like we had solid and liquid, this is where we have liquid and gas. So this would be your evaporation line or vaporizing. Again, you'll have both. Like if you put water on the stove, it's going to start to boil. Some of it's turning into a gas, but some of it's still liquid. As you get more and more gas, you get less and less liquid. And then when it's all gas, then the temperature can increase again. So up here is where we have all gas. So I want you to note a couple of things. One is that this line is longer, and that was on purpose. So it's a longer line because it takes more energy to convert a liquid to a gas than a solid to a liquid. So then this line. The other thing is, where are these temperatures right here? This one that matches that first flat line, this is your melting point or your freezing point. They're the same thing. It just depends on the direction. Are you adding heat or taking it away? And the upper one is your boiling point. So let's talk about what these phase changes. Let's make sure we know all these names. So last piece, solid to liquid is melting. Then liquid to gas is vaporizing. And you can talk about evaporation or boiling. They're all the same thing. And then if you go the other way, gas to liquid, that's condensing. So this is removing heat, and then liquid to solid is freezing. And then we can also add in these. You can skip liquid. So you can go right from solid to gas, and that's called sublimation. So this happens like with dry ice. If you have solid carbon dioxide and you put it like in the room and like on the counter, you would see it immediately turns into a gas. There's no liquid there. And then we can also go gas to solid, and that's called deposition. This happens with the moisture in the air, like in the morning, and you get frost on your car. It doesn't turn into a liquid. It just solidifies on the car because the temperature change is so great. Last thing I want to add to this is that we need to know that when we're going this direction, solid, liquid, gas, we are adding energy, usually in the form of heat. And when we're going this way, we are removing energy. Okay, and that these are phase changes. And that they are physical changes, not chemical. So we're talking about the same substance, just adding heat, changing state, removing heat, not turning into something new.